now look at the next question, that is question number 54. ABC are 3 points on the organ plane, of course represented by the complex numbers Z1, Z2 and Z3 respectively. Surely they form a triangle, and these points are taken in an anti-clockwise direction. Moreover, BC is to CA is to AB is equal to 2 is to root 2 is to root 3 plus 1. Then the imaginary part of Z3 minus Z1 by Z2 minus Z1 whole power 4 is asking us. A, B, C. In the anti-clockwise direction, they are to be considered Z1, Z2 and Z3. 3 complex numbers represented by the points A, B, C on the organ plane, thereby forming a triangle ABC. Okay, he has given that, what is given? BC is to CA is to AB is equal to 2 is to root 2 is to root 3 plus 1. Then imaginary part of Z3 minus Z1 by Z2 minus Z1 whole power 4. You please follow the question carefully. From the question itself, you are supposed to get the idea of making a beginning of the answering. Making a beginning of the answer. How to start with? Z3 minus Z1. What is Z3 minus Z1? It is CA. What is Z2 minus Z1? It is AB. AB and AC. AB and AC. Okay. With our general customary habit of properties of triangles from trigonometry, this will be denoted by small c, this side will be denoted by small a, this side will be denoted by small b. Okay, with that customary habit, we notice that, what do you mean by BC? A is to B is to C is equal to 2 is to root 2 is to root 3 plus 1. That is, A by 2 is equal to B by root 2 is equal to C by root 3 plus 1. Root 3 plus 1. Let me now calculate cos A. You may ask me, why should I calculate cos A? Why don't cos B or cos C? Because in the question, he is mentioning us Z3 minus Z1 by Z2 minus Z1. What is Z3 minus Z1? AC. What is Z2 minus Z1? AB. What is the angle between AC and AB? It is nothing but A. Therefore, cos A is equal to, what is the formula for cos A from properties of triangles? B square plus C square minus A square by 2BC. What is B square? 2. What is C square? Root 3 plus 1 whole square. What is A square? 4. What is 2BC? 2 into root 3 plus 1. Good. This is equal to 2 plus 3 plus 1 plus 2 root 3 minus 4 by 2 root 2 into root 3 plus 1. What is going to happen? 3 plus 1, 4. 4 go away, leaving you 2 plus 2 root 3 is nothing but 2 into root 3 plus 1 by 2 root 2 into root 3 plus 1. After getting it simplified, you will be going to get cos A is equal to how much? 1 by root 2. Therefore, A is equal to 45 degrees. Isn't it? A is equal to 45 degrees. then and there itself, we see and say that we are successful in estimating the argument of Z3 minus Z1 by Z2 minus Z1. Argument of Z3 minus Z1 by Z2 minus Z1 is equal to pi by 4. Is equal to pi by 4. Yes. Now, we could have estimated the argument of Z3 minus Z1 by Z2 minus Z1 only. But here, of course, our duty is to calculate Z3 minus Z1 by Z2 minus Z1 whole power 4. That part has been remained. We shall now get it solved. Basing on that, we see that Z3 minus Z1 by Z2 minus Z1 is equal to modulus of Z3 minus Z1 by Z2 minus Z1 into 6 pi by 4. That is, I could have expressed this bulkier complex number in mod amplitude form. This is R cos theta R into cos theta plus I sin theta as the otherwise 6 pi by 4. Yes, of course. Now, we can now estimate this also. What is mod Z3 minus Z1? Is nothing but mod CA. What is mod CA? It's nothing but B, that is root 2. What is mod Z2 minus Z1? Z2 minus Z1 is nothing but mod AB. What is mod AB? Mod C. What is C? Root 3 plus 1 into 6 pi by 4. 6 pi by 4. Well, we have noticed what Z3 minus Z1 by Z2 minus Z1 is. So far, we are able to estimate Z3 minus Z1 by Z2 minus Z1. But you see, we want to have fourth power of this. That is whole power 4. Whole power 4. Whole power 4. Isn't it? Okay. This is equal to root 2 whole power 4. What is it? Root 2 whole square, 2 square. That is 4. 4 by root 3 plus 1 whole to the power of 4 into 6 pi by 4 whole power 4. Let us use the De Moivre's theorem. It is nothing but 6 pi. What is 6 pi? Cos pi plus I sin pi. Cos pi plus I sin pi. That is nothing but minus 1. Therefore, minus 4 by root 3 plus 1 whole power 4. We could have estimated Z3 minus Z1 by Z2 minus Z1 whole power 4 is equal to 4 into minus 1 by root 3 plus 1 whole power 4. What could you observe? This is purely real. Is purely real. At this juncture, students may get confused because at last we could have got this answer and among the options it is not available. That is, you have not followed the question very carefully. He has asked us not the value of Z3 minus Z1 by Z2 minus Z1 whole power 4, but its imaginary part. As it is purely real, its imaginary part is 0. Isn't it? As it is purely real, imaginary part is clearly 0. Hence, what is the right option? Option A is the right option. That is, answer is 0. Right answer is 0. Right option is A. The next question, that is question number 55. In this question, he is giving two pieces of information about two complex numbers Z1 and Z2. One is mod Z1 by Z2 is equal to 1 and argument of Z1 Z2 is equal to 0. Then, which of the following possible cases we may observe? Option A, Z1 is equal to Z2. Option B, mod Z2 square is equal to Z1 Z2. Option C, Z1 Z2 is equal to 1. Option D, Z1 Z2 is equal to 2. Let us see what is going to happen. Mod Z1 by Z2 is equal to 1. That is, Mod Z1 by mod Z2 is equal to 1. That is mod Z1 is equal to mod Z2 is equal to R. Say. Let Z1 is equal to small r into cis theta. Small r into cis theta. Z2 is equal to small r into cis alpha. Cis alpha. But argument of Z1, Z2 is equal to 0. He is saying. He has given. What is argument of Z1? Theta. What is argument of Z2? Alpha. Argument of Z1, Z2 means theta plus alpha is equal to 0. Implies theta is equal to minus alpha, or alpha is equal to minus theta, or alpha is equal to minus theta. Therefore, Z2 is equal to R into cis minus theta. R into cis minus theta is nothing but Z1 bar, you can see. Isn't it? R into cis minus theta is nothing but Z1 bar. Okay, right? Therefore, Z2 is equal to Z1 bar, or Z2 bar is equal to Z1 bar bar, that is Z1. Multiply with Z2 on both the sides. Z2 bar into Z2 is equal to Z1 into Z2. What is Z2 bar into Z2? Mod Z2 square is equal to Z1 Z2. Therefore, what is the correct option? Mod Z2 square is equal to Z1 Z2 is the straight answer. Without any strain, we are having the answer very simply. So the right option is option B, and the right answer is mod Z1 square is equal to Z1 Z2. The next question, that is question number 56. Let Z be a complex number and A1, A2, A3, B1, B2, B3 are real numbers, then the value of, he has asked a big determinant. What is the determinant? Determinant containing first row A1Z plus B1Z bar, A2Z plus B2Z bar, A3Z plus B3Z bar. Second row B1Z plus A1Z bar, B2Z plus A2Z bar, B3Z plus A3Z bar. Third row B1Z plus A1, B2Z plus A2, B3Z plus A3. What is the value of the determinant? He is asking. First option A1, A2, A3 plus B1, B2, B3 into mod Z whole square. Second option A1, A2, A3 minus B1, B2, B3 into mod Z whole square. Third option 0. Fourth option mod Z whole square. Let us see what happens. What is the question actually? A1Z plus B1Z bar A2Z plus B2Z bar A3Z plus B3Z bar B1Z plus A1Z bar B2Z plus A2Z bar B3Z plus A3Z bar B1Z plus A1 B2Z plus A2 B3Z plus A3. a huge determinant, a very huge determinant. And if you look at the actual concept involved in that, you may laugh at it, how simple it is like that. Yes, you can write this determinant as, look here, A1, B1, 0, the first row. Z, Z bar, 1. First row, first column, multiply change. Multiply A1Z plus B1Z, Z bar, 0. A2, B2, 0. Second row, first column. A2Z, first row, second column. Multiply these two determinants, A1Z plus B1Z, A2Z plus B2Z bar, A3Z plus B3Z bar. It's very, very easy to look at that this bulk here determinant can be observed as the product of these two determinants. We need not find the value of the determinant, but the value of this determinant is 0. 0 into anything is 0. The product is simply 0. Therefore, the right option is option C. Yes. The only thing involved in answering this question is you must be able to express or observe that this determinant is the product of these two determinants. That's all. So the answer is 0. Option C. Now we look at the next question, that is question number 57. Sum of the common roots of the equations z cube plus 2z square plus 2z plus 1 is equal to 0 and z power 1985 plus z power 100 plus 1 is equal to 0 is, you are supposed to have the common roots of that equation. As usual, the options are there. Option A is -1, option B is 1, option C is 0 and option D is 2. That's immaterial. The thing that you must think of is the first equation is of third degree. At most 3 roots will be there. The second equation is of degree 1985. If at all there are common roots, the maximum number of common roots will be 3. You are supposed to pick out those 3 common roots if at all. We do not know how many common roots are there. Let us first of all gather those common roots. Well, let us start with an equation with a less degree, that is z cube plus 2z square plus 2z plus 1 is equal to 0. Z cube plus 2z square plus 2z plus 1 is equal to 0. No doubt it has 3 roots. 1 plus 2 is 3, 2 plus 1 is 3, so the sum of even powers of z is equal to sum of odd powers of z. Z is equal to -1 is a root, no doubt. Therefore, z plus 1 is a common factor, and if you pull that out, it can be taken as z square plus z plus 1 is equal to 0. It's very easy, very simple observation from the knowledge of polynomials. You can say that z plus 1 is surely a factor. How? Sum of odd powers of z, 1 plus 2, 3. Sum of even powers of z, 2 plus 1, 3. Same. You are able to observe that sum of odd powers of z is equal to sum of even powers of z. Hence, z plus 1 is a factor. By using the synthetic division or any elementary means you have at your earlier classes, you can split that into 2 polynomials like this. Well, what are the roots here? Z is equal to -1 from this And from this, that is a famous equation, that is equal to omega or omega square. These are the three roots of this. But about the second equation, let f of z is equal to z power 1985 plus z power 100 plus 1 is equal to 0. That is the equation. And only roots of this equation are minus 1 omega omega square. Let me calculate. What is f of minus 1? Minus 1 whole power 1985. Minus 1 plus 1, 0. Minus 1 whole power 100, 1. So, f of minus 1 is 1, not equal to 0, implies minus 1 is not a common root. The number of common roots has been lessened by 1. Only possibilities are omega and omega square. Yes, it is our duty to check whether they are common roots or not. What is f of omega? Omega power 1985 plus omega power 100 plus 1. Look at this. 1985. This is nothing but omega square. Why? Because 1983 is a multiple of 3. Remainder is 2. So omega square. Here it is omega. Why? Because this can be taken as omega power 99 into omega is nothing but omega plus 1 is equal to 0. We notice that omega is a common root for both the equations. Still, there is one more thing. Omega square is there. What is f of omega square? It is easy to see that it is also 0. Therefore, omega and omega square are the common roots. These are the only common roots, and every one of us know that omega plus omega square is always minus 1, and the sum of the common roots of the two given equations is minus 1. The right answer is minus 1 and the right option is A. Option A is the right option. The next question before us is question number 58. Let z be a complex number satisfying mod z plus 16 is equal to 4 into mod z plus 1, then mod z is equal to 4, mod z is equal to 5, mod z is equal to 6, and mod z lies between 3 and 6. What is the right option? Let us see. What has he given? He has given that mod z plus 16 is equal to 4 into, let us square it on both sides. What is mod z plus 16 whole square? Z plus 16 into z plus 16 bar. Z bar is mod z square, isn't it? So z plus 16 into z plus 16 whole bar is mod z plus 16 whole square. Just like that, you can write RHS also. That is you can easily trace this step because mod z plus 16 bar is z bar plus 16 bar, that is z bar plus 16, likewise RHS also. Now multiply it with the usual style of multiplication. Z into z bar plus 16z plus 16z bar plus 256 is 16 into z bar plus z bar plus 1. Well, 16z bar. Here it is z bar. There it was 16 z bar. Z bar is nothing but mod z square. So here is 1 mod z square. Here is 16 mod z square. So that you will have 15 mod z square. Now regarding the constants, here it is 256. There it was 16. Bring that 16 here. You will be having 240 here. So that 15 can be cancelled on both the sides. Mod z square is equal to 16. 16 15 is 240, isn't it? So that mod z1 is equal to mod z square is equal to 16. Therefore, mod z is equal to plus or minus 4 or 4. It is modulus. It cannot be negative. Therefore, mod z is equal to 4. What is the value of mod z? It is 4. The correct answer is 4. The right option is option A. It's very simple. Very simple calculation. The only thing, the only idea that one must possess is mod z plus 16 whole square can be written as z plus 16 into z plus 16 bar. Likewise RHS also. That's all the question. The answer is 4 and the right option is A. Option A. One more question, that is the next question is before us, that is question number 59. Z is a complex number satisfying mod z minus 2 minus I is less than or equal to 5. Then the maximum value of mod z minus 14 minus 6I is 18, 8, 7, none. Is asking us. He has given the nature of z, that mod z minus 2 minus I is less than or equal to 5. What does it mean? Mod z minus 2 minus I is less than or equal to 5. And he is asking about the value of, maximum value of mod z minus 14 minus 6I. Mod z minus 14 minus 6I. We are to estimate this, of course, by making use of that. That is, a very simple hint to follow is, you are supposed to create mod z minus 2 minus I at any cost. At any stage you must be able to observe here in the required one. This is the required modulus. Now, you can observe. How can we write this? This is mod z minus 2 minus I. Write it first of all. We want to have it at all, that's all. That is why I have written this. Now, this is minus 14, but here it is minus 2 only. Minus 12. So constants are balanced. It is minus 6I, but here it is minus I only. So still we must require minus 5I. Therefore, this is equal to modulus of z minus 2 minus I minus 12 plus 5I. Now, you take this as z1 and this as z2. From the earlier properties of modulus of complex numbers, we have mod z1 minus z2 less than or equal to mod z1 plus mod z2. Therefore, this is less than or equal to mod z1 plus mod z2. Okay. From data itself, this is less than or equal to 5, and from our earlier and easier straight calculation, modulus of this is nothing but square root of 144 plus 25. What is 144 plus 25? 169. Under 1 root 169 is 13. 13 plus 5 is 18. That's all the step required. This modulus of this complex number is less than or equal to 8. What does it mean? It can never exceed 18. So the maximum value is 18. The right answer is 18 and the right option is A. The next question in this session is question number 60. Omega is a complex cube root of unity, then the value of omega plus omega power. A big series is given. 1 by 2 plus 3 by 8 plus 9 by 32 plus 27 by 128 plus etc. up to infinity. So knowledge of series must be used here. How can it be used? In what way it can be used? Let us see. The answer for the answers he has given again as usual 4 options. The first option, option A, is I square, I cube and 0. They are the options. Let us now get it simplified. What is omega? Complex cube root of unity. That is, you must be using, you can use the properties of omega. That is 1 plus omega square is 0 and omega cube is 1. Let us simplify the given expression. Omega power 1 by 2, 3 by 8 plus 9 by 32 plus 27 by 128 is equal to K. Say, let me first simplify the series which occurs as the exponent to this omega. Let me simplify that. Half plus let me take half as a common factor. In the first place, 1 plus 3 by 4 plus 9 by 16 and then 27 by 64 and so on is equal to half into 1 plus 3 by 4. What is 9 by 16? 3 by 4 whole square, 3 by 4 whole cube and so on. One can easily see that the series given in these brackets is just nothing but an infinite geometric series. A geometric series with common ratio 3 by 4. 3 by 4 is less than 1. Hence, we can estimate the sum, the infinite sum, this sum up to infinity of that geometric series as a by 1 minus r with usual sense. That is half into a by 1 by 1 minus r. What is r? 3 by 4. What is 1 minus 3 by 4? 1 by 4. 1 by 4 it comes to the numerator 4. 4 into half is 2. Therefore, what is the value of k? Heroine of the problem. What is that? Omega plus omega power. This entire sum has been estimated to be equal to, come on, 2. What is omega plus omega square? It is minus 1. But you see, minus 1, is it available? Yes, observe carefully. I square is minus 1. Minus 1 can be written as I square. Hence, the right answer is I square and the right option is option B. That is the question. In solving this question, the crucial idea is you must be able to get half out to see the given series as a geometric series and thereby it could be easier to estimate it to be 2. So that the answer is omega plus omega square is minus 1, that is I square.